Hi everybody, this is Mrs. Lindsay. Today I'm going to do number 6 from your practice problem set number 3 on rationals. Again, just start by diving into this problem. I always, like to see, is anything going to factor and cancel? So in other words, I'm starting here with vertical asymptotes, domain, and holes, your removable discontinuities. Specifically, removable discontinuities. If it can factor and cancel, our vertical asymptotes are no longer vertical asymptotes, they are holes. But I can tell you right now, I know whether or not this factors, which I don't think it does, I know that 5 and -7, those are not compatible in terms of factoring. There is no way that I can get a -7 here. It has to be a factor of either 5, -5, 1, or -1 in these slots right here. I will never get a -7. So I know right away there are no holes, because nothing is going to factor and cancel out. Okay. If it factors, great, but it just doesn't. So in this case, we're going to just start by setting the denominator equal to 0 and solving so we get 7/2 as our vertical asymptote. And again, I'm going to go ahead and graph that right away. So that gives us 3.5. Again, as your dotted line, not the straightest there, but you get the idea. Okay. And then that directly relates to your domain. So -infinity to 7/2. And it's okay to use a comma here as well. A lot of times we use unions, but a comma or a union is either of those is appropriate. I believe I used union in problem number 1, and here I'm using a comma. Okay. So now let's address our other asymptotes. So we're talking horizontal and possibly slant. So if we look at our horizontal ones, we're looking at our degree terms here. Again, this is top heavy. So that means no horizontal asymptotes. We do have a slant. So now we're looking at either doing a synthetic division. Go ahead and erase this. Or long division. Well, we have to do long division in this case because we have, it's not x plus or minus a number. So let me go ahead and move down to the bottom here and set up the division. I believe I wrote this down correctly, but I'm going to double check before I pursue. Yes. Okay. So now again, 2x. How many times does it go into 4x squared? Well, that's 2x times. So I take the 2x and distribute it to the 2x and the 2x to the -7. So that gives me positive 4x squared minus 14x. And here's where I like to go ahead, change my signs, and add. This first one should always cancel out. If it does not, you've done something incorrectly, multiplied, added, something like that. Okay? So this cancel out. Now we add here. We get this to be 11x and bring down the 5. Now we repeat the process. How many times is 2x go into 11x? Well, not a great number. It's not like it's 10x, so we just multiply it by 5. So we have to think about this. 2x times what is going to give me 11x? Well, we need the 2 to cancel, and we need to have 11. The x needs to stay, so I'm going to multiply it by 11/2 because my 2 would cancel here. My x would stay, and I'd have 11x. So I'm going to multiply it by positive 11 over 2. So I take 11/2 times 2x gives me 11x. And now this one is going to be -77 over 2. Change your signs and add. This cancels, and we don't even care what this is. This is going to be some number. We don't care. There is going to be a remainder. We just care about this 2x plus 11. That is now going to be our slant asymptote here. So here's our slant of y equals 2x plus 11 over 2. Okay. Okay, so let's go ahead and graph that. So 11 over 2 gives us a y-intercept of, what's that going to be, 5.5. And then we have a slope of 2. So up 2 to the right 1, up 2 to the right 1, and I'm going to keep going with this. Up 2 to the right 1, and again, you're going to see, I'm kind of ballparking that. Obviously, I ran out of the graph. we have another little portion here from our graph where, I did not draw that very well. Let me fix that. Where we're probably going to have a little part of the graph right here, but we'll see when we keep finishing this. So again, I'm going to fill up my graph, keep going. It gives us just a guideline for our graph once we actually fill that in. Okay, and again, I'm going to skip in behavior. I like to do that last. And now I'm going to think about zeros and y-intercepts. So zeros, so again, if you recall, this denominator is going to go away because we set y equal to 0. So we literally are going to be working with 0. Oops, sorry about that. 0 equals 4x squared minus 3x plus 5. And this actually does factor, I believe. So let's see here. So 0 equals, no, really, I don't think it does factor. I scratched that. Oops. So again, our options are quadratic formula or completing the square. And again, I'm assuming most of you are going to choose to do quadratic formula, so I'll go ahead and do that. Plugging that in. So now we get this to be 3 plus or minus square root. I'll do the denominator first, which is 8. This is going to be 9. Now we have negative 4 times 5. So that's going to be negative 16 times 5. So we'll go ahead and do that. 3, negative 80. All right, so we can stop here. And I hope you realize why. This is going to be a negative underneath the square root. So we have no real solutions or no real zeros. They're going to be imaginary. So we actually have none. No x-intercepts there. Okay. So now our y-intercepts, again, if you recall, this becomes 0, this becomes 0, this becomes 0. So we're only really looking at 5 over negative 7. So that'll be 0 comma negative 5 over 7. And we can graph that. Be in between 0 and negative 1. And we'll just verify this with the calculator, especially since I have this little portion up here. Probably going to have a graph there, but we'll double check that. So let me go ahead and plug this in. Move this over. So clear this out. 4x squared minus 3x plus 5 divided by 2x minus 7. Make sure I plugged it in correctly. Got parentheses around my numerator, parentheses around my denominator. Oops, I should go to my standard window. This is going to be a little skewed, but we can go back to the original. And you can see, yes, there is a little portion up here. Kind of forms this X. Let me go back to my standard window, and you can see I don't even believe it shows up in your standard window because it's so far off of this graph here. Yeah, and that is correct. So, and again, you don't really have to worry about it. But if you want to put a little portion up here, and then this guy comes around here like so. And you can use the table feature. You can find some more exact values. You can plug in. Here's the table feature. So again, you're trying to always fill in your gaps, right? Somewhere here, make sure there's nothing in this quadrant, something here, make sure there's nothing here. So you're trying to plug in your x values here, which would satisfy either one of those. Your x values over here, so it would satisfy either one of those. So again, you can plug those values in and see what you have there. Okay, you can do it whether you do it with a calculator, whether you do it by hand and make a table. Again, you're simply just trying to fill in your different quadrants that you have of your graph. Okay. All right, so this concludes problem number 6 from practice number 3.